tema Borg, with a talk titled What's the Basis of Social Cognition.
Thank you. Okay, so thanks very much everybody, and thanks to Augustine for organising a great conference, and my apologies for missing some sessions yesterday. And can everyone hear me? Yes. And more importantly, my apologies because this paper is a little bit more work in progress than it was really supposed to be by this stage, by the stage of presentation. So I'm hoping you can all kind of help me fill in the gaps as we go along and point out where the gaps are. Okay, so I want to talk about social cognition. And I'm going to suggest to you that there are two different accounts of social cognition on the table at the moment. And then I'm going to look at those two accounts with respect to the question of nativism, and I'm going to ask which of those two accounts looks the more plausible. So what got me started thinking about this kind of question was really doing some teaching. I was doing some second year teaching, and one of the things we were covering was the problem of other minds. And it struck me that really that was a bit misleading, that there's not a single problem of other minds that we're interested in. There's really a kind of cluster of different issues that we might be interested in. And so here's at least three of the kinds of questions we might be thinking about when we're thinking about the problem of other minds. So the kind of classic problem that I was teaching to my second years in epistemology was this kind of classic Cartesian skeptical worry. You know, how do we know that there's any other minded individual out there in the world around us? So that's the Cartesian worry that, you know, there could have been a really clever demon that replaced everyone around you with sophisticated robots or automata, and you wouldn't know. You wouldn't see any difference in their behaviour, and so it would never be accessible to you that change had happened. And if you didn't know the change had happened, then the Cartesian question is, well, what right have you got to think that you're in the non-skeptical scenario? So there's a kind of epistemic version of the problem of other minds, and then there's a kind of qualitative version of the problem of other minds, the idea that it's a kind of subjective states worry. So that's the kind of Nagel take on the problem, the idea that you'll never know what it's like to be a bat, the kind of problem that arose recently with the mention of the dreaded internet dress, you know, the idea that you never really know what someone else's subjective experience is like. And then finally, there's a kind of practical worry, you know, an idea about how you get on in the social world in which you live. So the question of how you predict and explain the behaviour of other people. And I think these three questions probably don't exhaust the problem of other minds, and they're clearly related in interesting kinds of ways. And if I was giving a longer version of the talk, I think I might try and say something about the way that I think these different questions hook up. But as it is, I'm just going to ignore really the first two versions of the problem and focus on this predictive question. So when I'm worrying about other minds in today's talk, what I'm going to be worrying about is that question. How do you predict and explain the behaviour of others? Okay, and as I said, I think that there are two broad accounts on the table at the moment for answering that question, for answering the question of how we predict the behaviour of a conspecific. And I think it's maybe worth noting, if I'd been giving this talk, I don't know, 10, 15 years ago, and I'd said to you, there are two broad accounts of how we do this behaviour prediction on the table, the two accounts you would have immediately called to mind would have been simulation theory versus theory theory. Okay, they used to be the two big beasts around here. That's not the division that I'm going to be interested in today's talk. I think the debate has moved on a bit from there. And it's an interesting question about how that old divide between theory theory and simulation theory maps to the divide I'm going to give you today, but I think it cross-cuts it in various interesting ways. So the distinction that I'm going to be interested in then is the distinction between what I'll call mind reading, which incorporates kind of traditional theory approaches, but probably isn't limited to them, and what I'm going to call smart behaviour reading. So a mind reading account for me is any account which mentalizes, right? Any account which attributes mental states to another and uses those as part of the explanatory framework. So the idea of mind reading then is that A witnesses B's behavioural and environmental cues and uses these to infer B's mental state. A then uses these attributed mental states to predict and explain B's behaviour. So the idea is, I see Jill come into the room and she's red in the face and she's sweating and she's wearing running gear and she goes over to a tap and she fills a glass with water. And I use those environmental cues, the way she looks, what she's wearing, what she's doing, in order to make an inference about her mental states. So I infer that Jill is feeling thirsty and that she wants a drink, and on the basis of those attributed mental states, I then predict that she's going to drink from the glass that she's filling. So that's a classic kind of mind-reading account. But the alternative account says that you don't need to take that extra step through the inference of mental states. It's a kind of deflationary account of the way in which we go about predicting behaviour. So what I'm calling smart behaviour reading then, A witnesses B's behavioural and environmental cues, and they predict and explain B's behaviour on the basis of these cues. So with the running case again, you see Jill, you see that she's hot and red in the face, you see that she's filling a glass from the tap, and that alone allows you to predict that she's going to drink from the glass. Because those kinds of cues are just reliable indicators of the next kind of action, the drinking action. So on this kind of behaviour reading account, then we don't need the extra trip through mental states. And this kind of more deflationary approach, this behaviour reading approach, is really growing in popularity in this area. And in particular, there's a nice version of it here, or a nice version of the problem from Povinelli. So Povinelli has really pushed this idea of smart behaviour reading in the comparative domain. So here's Povinelli and Vonk, and they say it must be conceded that the subject's predictions about the other agent's future behaviour could be made either on the basis of a single step from knowledge about the contingent relationships between the relevant and invariant features of the agent and the agent's subsequent behaviour, so that's smart behaviour reading, or on the basis of multiple steps from the invariant features to the mental state to the predicted behaviour. Without an analytical specification of what additional explanatory work the extra cognitive step is doing in the latter case, there is nothing to implicate the operation of a psychological system S, which involves behaviour and mental states, over a psychological system which involves behaviour alone. And obviously the conclusion Povinelli is going to want us to draw from this is that there's no additional analytic specification of the work that mental states do for us. In general, at least in the primate case for Povinelli, we could get away with just having a kind of smart behaviour reading psychological system. All of our prediction of action might run via that. Okay, so here's one of my pictures, just to keep people awake first thing in the morning. Nice, attractive looking chimpanzee, very nice. So as I was saying, this particular version of the smart behaviour reading approach has really come to the fore in the comparative literature. Okay, so Povinelli's claim isn't going to be necessarily that what we're all doing all of the time is just smart behaviour reading. The thing he's really interested in is the question of whether we need to attribute mentalising to our great ape relatives. And his conclusion is probably not. We can probably get away with a smart behaviour reading account of all of the interactions that they engage in. But although it's come to the fore in the comparative domain, you can definitely find these kinds of behaviour reading accounts as accounts of the kind of thing that we do as our own default account of action, prediction and explanation. So I think the mind-shaping account that we were looking at yesterday might fall under this kind of more deflationary approach, kind of narrative approach that Hutto gives us falls in the kind of accounts I've got in mind here. All of the kind of embodied, inactive types of approaches are the kinds of accounts that I have in mind as accounts that say that we engage in prediction and explanation of action without taking the extra trip through mental states. And clearly, when we're thinking about our own case, we're not going to say that we never attribute mental states, because there's verbal testimony that we do engage in kind of mentalising attributions. But the question would be, in our own case, could this at least be the default method of prediction and explanation? Could it be that usually all we're doing is behaviour reading? So 2 questions for this kind of behaviour reading account then. What might a behaviour reading psychological system for humans look like? And could smart behaviour reading be our default method of behaviour prediction and explanation? So those are the 2 kinds of questions I'm going to look at right now. So on the first question, what might it look like? Well, as I just said, there are a range of accounts out there that fall under the kinds of accounts I'm interested in here, the narrative approach, various embodied accounts. But it seems to me that the most kind of concrete proposal here emerges from the mirror neuron literature. So that's the account that I'm going to look at because it seems to me to be the most clearly specified version of this behaviour reading account. So as many of you will know, mirror neurons are neurons which fire in two distinct conditions. Okay, they fire when you perform an action, and they fire, see my neurons are going off for answering phones right now. That's fine for us. They go off when you perform an action, and they go off when you see a conspecific perform an action. So if I perform a whole-handed grip on a bottle, all your mirror neurons for whole-handed grips are firing when you watch me do this, in just the same way that mine are firing when I perform the action. And the suggestion has been that maybe that behaviour, that sort of mirroring, motor mirroring behaviour, is what underpins our recognition of the intentional actions of others. So we come to understand the action of others through this kind of mirroring, or what we might also call motor resonance. Your grip of the glass triggers a motor plan for drinking in my mirror neuron system, but because I'm watching you perform the action, not performing the action myself, instead of taking that as my own intention, I tag it as belonging to you. Okay. So I see your actions as intentional because they're firing up my mirror neurons, and those mirror neurons constitute intention formation in my own case. So seeing your movements allows me to know directly about your action plans without any kind of hypothesizing about the mental states, about your mental states. So this would count as a clear behaviour reading, deflationary approach to action prediction. So one question I think we might have for this kind of mirroring approach is exactly what's meant by mirroring. Okay, so it's not always clear in the literature what kind of mirroring we're interested in, and this will come up again later as well. There are at least three things, I think, that get picked out as mirroring. There's the way I just put the mirroring claim, which was in neural terms, okay? The activation of mirror neurons where that's recorded by some kind of brain scanning. So the most robust evidence for the mirror neuron system in terms of brain scanning is to do with single cell recordings. So that's what we get coming from the primate literature, but to get individual single cell recording, that's an invasive technique. So we don't have that kind of evidence for mirror neurons in the human system because you're not allowed to do that kind of thing. So in the human system, it comes from fMRI and other forms of brain imaging. So that's one way in which mirroring is talked about, this neural instantiation. But we also get mirroring being talked about in terms of matching of muscles. So this is particularly the case in the research on facial mirroring. So in this case, you count as mirroring someone when there's activation of matching muscles, even if that activation is at too low a level to result in observable action. So for instance, if you see someone smiling at you, it turns out that you activate the muscles for smiling back at them, even if it doesn't result in a facial smile. Okay, there's activation to those matching muscles. So we have different forms of recording that, but that's often taken to be evidence for the mirroring system as well. And then finally, there's the sort of most high-level mirroring, which was talked about a little bit in yesterday's mind-shaping paper, this idea that we engage in kind of observable mimicry or confirmation to another person's actions. So we tend to match facial expressions with people we're talking to, we shadow their bodily movements, people will come to reflect the bodily posture and the gestures of others that they're engaged in order to create a kind of social framework, to strengthen social bonding. So all of these things get referred to as mirroring, and they're all taken to be evidence for the mirror neuron system. But I take it that one question we might ask right away is what the grounds are for thinking that this is all evidence of a kind of single unified system, you know, the mirror neuron system. And one reason we might have for being a bit sceptical about that is that the degrees of control or cognitive penetration in each of these cases seem kind of different. So I take it that if my mirror neurons fire just when I see you perform a whole hand grip on a cup, there's nothing I can do about that, right? They're just going to fire because that's the kind of thing mirror neurons do. They're not really influenced by any higher level control. But if we look at the observable mimicry, that seems much more kind of penetrable to at least some degree. Okay, so there's good evidence that we engage in this kind of observable mimicry much more depending on things like power relations, perceived power relations in the situation. In certain situations, you're more likely to mimic the bodily posture of someone who has a higher power status than you do. And that kind of penetration to really quite, abstruse features of the situation, quite abstract features of the situation, like social hierarchy, seems to show that observable mimicry is more penetrable than the straightforward neural mimicry. Okay, so we'll come back to this a little bit later on when we look at the evidence for the mirror system, but I think one question we might have is whether people are always talking about exactly the same kind of thing when they talk about mirroring. And really in what follows, I'm going to try and concentrate on the neural implementation version of the mirror neuron thesis. So thinking about that then, so thinking about the idea that I get to know about what you're going to do because my brain is somehow doing the same kind of thing as your brain when you engage in actions. Could it really be the case that that kind of mirror neuron activity underlies the attribution of attentions? Well, one immediate worry we might have with this kind of approach is that, look, if mirror neurons are sensitive just to kind of what I'll call kinematic gestures, just to grips and shapes of hands, that clearly underdetermines attribution of intention, right? My whole hand grip of this bottle will be the same kind of action whether I'm intending to have a drink from it or whether I'm intending to tip it all over Chris. Actions underdetermine intentions right up until the kind of final point where it becomes clear what I was intending to do. So if all we've got from the mirror neuron system is this kind of kinematic tracking, it doesn't look like it's the kind of thing that's going to give us intentions. But the mirror neuron advocates are very aware of that kind of worry, and they think that it doesn't hold. Okay? And they think that it doesn't hold because they think that mirror neurons aren't just sensitive to kind of broadly construed kinematic gestures. I think it would be a mistake to say that all the mirror neuron system does is track, grips and grasps. So they say that some mirror neurons really do respond just to the, the physical description of the action, the grasp, whether it's precise or whole hand. Those are kind of broadly congruent. Those are narrowly congruent mirror neurons. But others, they say, are what they term broadly congruent. They respond not to the brute kinematic gesture, but to the overarching intention. So the reason that the action is being performed for. I'm not going to give you all the data that they try and appeal to here, but two of the kind of key experiments that are supposed to show this, probably two of the most famous experiments in this area. Fagassi's lab did an experiment which was supposed to show that the mirror neuron system was capable of distinguishing between a reach to eat and a reach to place, where those two actions were kinematically very similar. So they had a monkey that had a box in front of them and could reach to take a piece of food and could either place the piece of food in their mouths or could place it in a box on their shoulder. So those two actions are kinematically very similar. Physical gestures are almost matching. And they found that a monkey that was watching those two actions would have different patterns of mirror neuron activation in the reaching phase, depending on whether the action culminated in a reach to place or a reach to eat. And they took that as evidence that the mirror neuron system was sensitive to the kind of overarching chain of actions that an action was taking place in. So the system was capable of distinguishing what looks like two similar physical gestures in terms of the overarching action goal that those actions were subserving. And a second experiment that's supposed to show the same thing, Umuta's work with what they called reverse pliers. So with a pair of pliers, they used pliers to break nuts and showed the monkeys the breaking of the nuts using the pliers. And with an ordinary set of pliers, what you had to do was squeeze the handle in order to exert pressure and break the nut. And then they created reverse pliers where you had to perform the opposite kind of kinematic gesture. So you had to push the handles away in order to exert pressure and break the nut. So two diametrically opposite gestures, squeezing versus pushing, but both subserving the same action goal, both resulting in cracking a nut. And they found that the monkey's mirror neuron system fired in the same way in response to those two different gestures. So it would fire in the same way for the squeezing and for the pushing seeming to show that it was recognizing that both actions were part of an overall action goal to crack the nut. So this is supposed to be the kind of evidence that shows us that maybe mirror neuron systems can track intentions, not just kinematic gestures. And the answer to how they do that is supposed to be that it's not just a single mirror neuron that embeds recognition of an intention or an action goal, it's a whole mirror neuron chain. So why the mirror neuron system recognizes a movement as a grasp to eat versus a grasp to place is that it's firing a whole chain of actions, a whole chain of mirror neuronal motor actions, one of which culminates in a placing and one of which culminates in an eating. So here's that point put by the philosopher of the mirror neuron bunch, which is Corrado Sinigalia, and he writes, "It is due to this motor chain organization that grasping is not just grasping for grasping's sake, but it's grasping to carry food to the mouth and eat, or grasping to move X from A to B, and so on. It is a question of recognizing the role of chains of motor goals, and the fact that they shape the motor expertise which is at the base both of the agent's capacity to act and to represent his or her own actions, and his/her ability to understand the immediate significance of the actions and intentions of others." So this is the idea that the mirror neuron system is going to underlie our own recognition of our actions as intentional and underpin the recognition of the intentions or the action goals of others. And it's going to do this by this firing of motor chains. So I think there are various kinds of worries that we might raise with this kind of account, but right now I'm going to set those to one side, and I'm going to ask a question about how these neural chains are supposed to come into existence. So this is going to take us on to think about the nativist debate, and about how, if this is the right account, if we really do have a mirror neuron system which has these chains of mirror neurons in it, how do those chains of mirror neurons get in there? Are they things that we're born with, or are they things that we learn? So if we look at the original advocates of this kind of approach, they seem to be appealing to the idea that the chains are innate. Okay, so there's a lot of talk of pre-wired motor chains. Agassi in particular likes this phraseology. So the idea is that there are pre-wired motor chains embedded in the mirror neuron system, and the combination of witnessing a target perform a small-scale action in a precision grip of an object or a whole hand grip of an object, together with the context in which it occurs. So I think context has a role to play in getting the mirror neuron system to locate the right chain. Those two things trigger the activation of one or other of these pre-wired chains. So we come kind of equipped already with an idea of overarching action goals, and something about a particular action in a particular context gets one of those chains firing off the ground. And it's this activation which constitutes activation of, in the subject's own case, or attribution of, in the observation case, a plan to grasp to drink, or a plan to grasp to place, or whatever. So why might we think these chains are innate then? What evidence would we have for thinking that a nativist account is the right way to go? Well, one of the big bits of evidence people like to appeal to here is the famous, or maybe infamous, evidence to do with neonatal mirroring. And notice that we've moved now from thinking about neural mirroring back to this kind of notion of observation mirroring, right? The observable mimicry behaviour. So this is the really famous paper by Miltzoff and Moore, where they found evidence that incredibly young infants, so this is 2 to 3 week old infants, would imitate facial gestures of caregivers. And the suggestion is that, these children are so young, 2 to 3 weeks old, they haven't had time to learn how to perform these actions. So there must be some kind of innate system subserving this mirroring kind of behaviour. And linked to that is something we might call the correspondence problem. So mirroring, this time the other way round, by the adult of the infant. So the mirroring we were interested in just now was by the infant of the adult, right? So the adult sticks his tongue out and the infant sticks their tongue out. That was the kind of neonatal mirroring that Miltzoff and Moore were interested in. But it also works the other way around, right? Adults will mirror what the infant is doing. If an infant smiles, an adult will smile back at them. And that kind of mirroring by the caregiver of the infant plays an important developmental role for the infant. Okay, so this is work by a colleague of mine at Reading in Murray, who's shown that that kind of mirroring performs an important developmental role because it increases the amount of social gestures that an infant will go on to perform. Okay, so if a very small infant, 2 to 3 weeks, smiles and you just make kind of jolly noises or don't mirror their face, that just positive response to them will increase the amount of smiling or other social gestures the child will perform in the next short window of time, the next kind of 15 minutes. But if you mirror the action, it turns out that that increases the amount of social gesture the infant will perform in the next week. So it has this kind of long-term increase effect on the number and the amount of social gestures that a child performs. But the worry is that although it plays this important role, the infant has no feedback for its own facial gestures. Okay? It can see its hands, and it can see your hands, so it could know when it's being mirrored in terms of its, the movement of its hands or its other bodily parts, but it has no visual feedback for its face. So the question is, how does the infant know when it's being mirrored in facial terms? How does it know that when it's smiling and you smile, that that's a mirroring action? Because it can't visually match the two of them. So the suggestion is that without an innate system matching motor and visual representations for the face in particular, how could an infant know when it's being mirrored and when it isn't being mirrored? And if it doesn't know when it's being mirrored versus not mirrored, how could facial mirroring play this important developmental role? So the suggestion again is that there must be an innate underpinning for at least facial mirroring in this case. So as far as I'm aware, those are the two main arguments that are given for this innate mirroring capacity. But I think there are some worries for this kind of approach. So one of the big worries is that a lot of weight is put on this neonatal mirroring by the infant of the adult, so melts off more stuff about the tongue protrusion or the open mouth. But that literature remains very contentious. Okay, it's not been settled one way or the other. So in a survey of the metadata by Ray and Hayes in 2011, they didn't find any evidence from a range of experiments which have attempted to repeat Meltzoff and Moore's findings. They didn't find any robust evidence that there really was this kind of facial mirroring in neonates. And the problem for this kind of experiment is the types of behaviour that Meltzoff and Moore were interested in are types of behaviour that are quite common in neonates anyway. And the amount of occurrences of that behaviour, the tongue protrusion or the open mouth, that sort of behaviour increases on occasions of infant arousal. So the more excited the baby is, the more it's going to explore its world by sticking its tongue out, the more it's going to open its mouth. And the kinds of experimental situations in which you're looking for that information are going to be the kinds of situations in which the infant is aroused. So you're going to increase the kinds of occurrences of those behaviours, and so you're going to increase the chances that you've just by luck got a matching when you do a mirroring. So it's not been settled one way or the other, but the literature remains contentious. Furthermore, mirroring amounts to less than 3% of infant caregiver interaction. Okay, it's a very small percentage of the way in which caregivers interact with 3 to 4 week old infants. And the window in which it has an effect is also very small. So Murray's work claims that you get this increase in social gestures in just this very small window when infants are over 5 weeks, because you can't really recognise a social gesture under 5 weeks, they don't smile under 5 weeks, and up to 8 to 12 weeks, because at that point they lose interest in facial mirroring anyway, they lose interest in faces to a large extent, and they start looking around the world much more. So the points in which you get this increase in social gesture just from mirroring is very small. And so the idea that you really require this innate mechanism just for this small increase in this small window seems to me kind of expensive. And I think that innate models neglect of infant mirroring, neglect the amount of attention that infants pay to their own hands and their own bodily parts in the early stages. So this is kind of anecdotal, but you know, If you watch a neonate, they wave their hands around a lot and they're fascinated by looking at them. And at least one interpretation of what's going on there is that they're busy trying to construct a mapping between seen gesture and felt gesture. You know, if they already had that kind of innate system set up, you might wonder why they spend so much time staring at their own hands. And related to that, it's not obvious to me that this correspondence problem, this kind of conceptual worry for the mirroring behaviour, really does hold. So the correspondence problem is that, you know, they've got no visual feedback for their own facial gesture, so how could they know that they're being mirrored? But I think you need to be really careful here about how you conduct these experiments, because if you look at caregiver responses to children, you know, kind of in the wild, as it were, outside the lab, when these kinds of mirroring relations hold, there's an increase in the amount of feedback that a child gets. Smiling parents are really pleased when their neonates smile. It's a breakthrough in the kind of connection between them and the child. So there's a huge increase when there's this matching of mirroring. And that alone might be able to explain how the infant knows that it's hit on a mirroring gesture. Or alternatively, I wonder whether there might be a possibility of a kind of bootstrapping account here. So the worry is that there's no way for the infant to match seen facial gesture to felt facial gesture. But if you think of the infant as having a kind of felt body map that it's trying to pair up to a seen body map, it's able to match elements of its felt body map to elements of its seen body map. So it can it can see a hand moving, and it can map that to its own hand. It maps motor gestures as seen and felt. But if it can map parts of its bodily map to parts of its seen body map, then it might be by kind of abduction it can work out where the face is in relation to other elements that it can see. So by seeing the movement of a hand, it might begin to locate hands in the, with relation to the felt body map, and that might allow it to then map seen facial gestures to felt facial gestures, even if it hasn't got visual feedback of that element. And finally, even if we went for this kind of innate model of mirror neuron relations and mirror neuron chains, there would still be a really big question as to how an individual selects the right mirror neuron chain on any given occasion. So to go back to the Fugazi view, we've got these mirror neuron chains for reaching for placing and for reaching for eating. But in a given situation, how do I know which of those chains should be firing? The answer has to be that I look to something in the context in order to help me do that. So there still has to be a really big role for contextual input, even if we thought of the brain as innately populated with these multiple chains of mirror neuron activity. So I think there are some worries for the innateness model, and furthermore, I think the innateness model looks seriously problematic when we look at the evidence for the idea that these mirror neuron chains are learned. So the idea that mirror neuron chains are learned would be that we witness specific actions which lead to a behavioural outcome during the learning phase. Habituation to these actions in a context leads to anticipation of the habitual outcome when later exposed to a similar stimuli. So I've learned that this kind of action usually eventuates in this kind of outcome, and when I see that kind of action, I just expect that later kind of outcome. So one bit of evidence that might support this kind of claim then is the idea that monkeys, experiments have shown that monkeys who are deprived of the sight of their own hands from birth are later unable to perform visually guided movements. Not a particularly nice bit of experimental work here, but it turns out that if you're depriving an individual of seen action at an early age, they can't map seen action to felt action. They can't visually guide their hand movements in the way that typically developing individuals can. And that might point us in the direction of the idea that the mirror neuron system requires early exposure to visual stimuli. That doesn't necessarily show us that we haven't got an innate system, because it would be compatible with the idea that there really is an innate system, but it requires early exposure in order to get that system up and running. So it's not conclusive, but it might point us to the idea of the role of environment. But a stronger piece of evidence, I think, comes from Celia Hayes and her team, who have shown that you can manipulate mirror neuron activity through training. So Hayes' experiment here, what she did was she took subjects and she showed them displays of hands. And she showed them a display in which the first finger was lifted. And what happens when you see a display of a finger being lifted is that your mirror neuron system for lifting your own first finger fires. Okay, so you don't necessarily perform the action, but your mirror neuron system does. But she then instructed her subjects that when they saw a lifting of the first finger, they should perform a non-congruent gesture. So they should lift their little finger. So every time they saw a lifting of the first finger, they performed a lifting of their little finger. And after really quite a short number of trials, she then found that if they just saw a lifting of the first finger, that was sufficient to fire the mirror neurons for lifting their little finger. So you could change the patterns of mirror neuron firing depending on environmental conditions. And that seems to show that what's going on in the mirror neuron system is this kind of associative learning, right? It's learning about typical outcomes in a range of situations. And that looks to me like pretty knockdown evidence that what's going on in the mirror neuron system is a learning system, not an innate, pre-wired set of intentional chains. So let's assume then that we accept that idea, that mirror neurons are a learned behavior tracking system. So associationist training of mirror neurons, I think, points to the idea that mirror neuron chains are learned contingencies. They're not innate pre-wired systems. So I'd suggest that the mirror neuron system might be interesting, but it might be interesting because it provides a neural system for the statistical tracking of behavioral contingencies. It's recognizing learned relations between behaviors. So to go back to the original claim, what might that show us then? Could that kind of behavior reading system be our default method for predicting and explaining the behavior of others? Is what we're doing most of the time just this kind of smart statistical behavior tracking, maybe underpinned by a system like the mirror neuron system? Is it the case that A performs motor act M and B predicts that A will go on to do M star just because B's mirror neuron system has learned to associate movement N in context C with action goal M star? So that's the question I'm interested in now. Well, it seems to me that some of our social interaction does indeed fit this kind of behavior reading model. If you think about behavior in stereotypical kinds of situations, it seems to me that we really are running just on this recognition of kind of what's most likely to happen next. So in sports activities, in driving, in shopping, in any kind of activity where what I call a script or a schema, the idea that you can write a set of kind of predicted actions or rules for the behaviour and the interaction, in any kind of interaction which could be in principle made automatic, those seem like good candidates for explanation via smart behaviour reading. Okay, those kinds of really sort of rule-governed, formulaic social interactions that we engage in, absolutely, I think, could be subserved by this kind of smart behaviour reading. But the worry I have with the sort of deflationary approaches that like this kind of account is that they just go too far. They think that this could be our default method of behaviour prediction and explanation, and that seems a mistake to me. So why do I think it's a mistake then? Why do I think that there'd be a problem to think that this kind of behaviour reading was our default method of social interaction, explanation and prediction? Well, one worry, and I'm not quite sure I want to endorse this worry, but I'll give it to you because it's out there, is a worry that's been raised by Peter Carruthers in a range of places. And it's the worry that if we just treated both the great apes and ourselves as kinds of smart behaviour readers, we wouldn't have any explanation of the experimental data that we find. So the experimental data is that we, from a certain age, pass all kinds of false belief tasks, but no other primates seem to manage that. So the great apes consistently fail any variety of false belief tasks that you can give them. And Carruthers' worry is that if you think that we're just doing exactly the same thing as the great apes, there's no explanation for that difference in the experimental results. So that might be one worry with this kind of behaviour reading approach. A more substantial worry for me is the thought that a lot of the behaviour prediction and explanation we engage in is kind of character-based or trait-based. Okay, why do I think someone is likely to do something? Well, it depends on the kinds of characteristics I think that person has, where those characteristics seem to me to make ineliminable appeal to mental characteristics. So I think I gave you a kind of toy example on the handout. You know, I'm looking at a class of 9-year-olds who have just been asked a question about their maths homework. And I'm wondering to myself whether Jill is going to put up her hand to answer the question. So on the one hand, I've got good statistical evidence that girls in what are called in the UK STEM subjects, you know, the science and the maths subjects, tend to engage less in class interaction than boys do. So they tend to raise their hands less in answer to questions. So on the grounds of sort of statistical relations, I may predict that Jill's not going to raise her hand. But on the other hand, even though I've never seen Jill in class, I may know some things about Jill. I may know that she's worried about female representation in the maths and the sciences. I may know that she feels that she should interact in these kinds of cases. So on the basis of knowledge of her character, I'm going to make the prediction that she's going to raise her hand. And it seems to me that those kinds of explanations, any kind of behaviour prediction, where we have to appeal to the agent as the individual that they are, as the person with the character that they have, has to avert to mental states. We can't give a purely statistical account of those kinds of character-based explanations, and it seems to me that a great deal of the action prediction we engage in is of that form. Furthermore, if we think about counterfactual reasoning about actions, which is an incredibly useful heuristic for us, none of that seems to me to be possible without consideration of mental states. We can't just have this close mapping between behaviour, sort of seen environmental cues, and behavioural outcome when we want to consider a counterfactual situation. Would Jill have raised her hands if she thought that someone else was in the room, for instance? Those kinds of counterfactual considerations, again, require appeal to mental states. I know this is something Chris doesn't agree with, but it also seems to me that communicative language use essentially involves recognition of the intentions of another. Someone tells me that it's raining. How do I know whether they're communicating that the picnic is cancelled, or that they're happy because the ducks are going to get wet, or any of the absolutely indefinite number of propositions they might be communicating by the same utterance of the sentence, it's raining? How do I get at any of those? Well, I want to agree with Bart Gertz in a recent paper that there's just no way to do that except by considering the intentional states of the other, except by thinking about what they intend to get across to me. And since a great deal of our behaviour prediction and explanation rests on linguistic evidence, I think that's a clear case where our default method can't be the behaviour prediction method. Okay, and also I'm worried about circularity here. I think identification of the context and thus individuating which behavioural regularity is in play itself often requires appeal to mental states. Okay, so there's a good behavioural statistical regularity between people who haven't eaten for a while, who have food put in front of them, eating the food that's been put in front of them. But there's also a really good behavioural statistical regularity between people who haven't eaten for a while and have food put in front of them, but don't like the food that's been put in front of them, not eating the food that's been put in front of them. So how do I know which of those situations I'm in when I see someone who I know hasn't eaten for a little while have food put in front of them? Can I predict that they'll eat or they'll not eat? Seems to me I can't even begin to individuate that situation until I know something about the mental states of the agent that I'm trying to predict. Do they think the food is poisoned? Do they think it's going to taste good? I can't even get my behaviour tracking system up and running until I've thought about the mental framework that's in play. So what I want to suggest to you then is that there's something right about the behaviour reading system. Okay? It gets a right account of behaviour prediction and explanation when we're thinking about certain kinds of stereotypical behaviours. But we also really genuinely require a full-blown mind-reading or mentalising system. We can't do away with that, and it would be wrong to think that somehow the default method is the behaviour reading, and we save the mind reading for these kind of special one-off conditions where we're consciously wondering about things. So I think there are two systems. So is this a two-system solution? Okay, when you talk about two systems, it brings to mind the Kahneman-Tversky stuff about one system of quick heuristics and one system of slow, deliberative stuff. I do think there's two systems, but I think that that kind of classic two-system solution would be the wrong way to think about this. Because the distinction between behaviour reading and mind reading cross-cuts those sort of related issues about speed and conscious access. So I think there are two systems, and when one system is impaired or fails, it may be possible to recruit the other one to take over. You know, sometimes where we're in a stereotypical situation like a sports game, but someone starts engaging in behaviour that was unexpected, I may then flip to thinking about a mind-reading system. Well, why did they do the thing they did? But even though I think there are these two systems and that they operate in this related way, and that sometimes you may flip from the other in kind of conscious ways, I think it would be a mistake to think that the behaviour reading, mind reading distinction tells us anything about which system is fast or automatic and which system is slow or deliberative. I think both systems can be used in both kinds of ways. Sometimes behaviour reading is fast and automatic, sometimes it's slow and deliberative. You know, what exactly which behaviour was I witnessing there? What kind of behaviour is it going to outcome in? Sometimes mind reading is absolutely fast and automatic. I don't have to think to myself, is this person believing that P and desiring that Q and therefore doing this other thing? Sometimes it's tacit and automatic and fast, and sometimes it's deliberative and slow. So both systems are capable of operating in both kinds of ways. So I do think there are the two systems. So oh my God, shall I stop? Yes, do 5 minutes? 5 minutes, okay. So I have really very little to add to this anyway. So just on the last question, the idea of whether or not the mind-reading system should be thought of as innate or acquired. I haven't got a whole lot to say. This is a well-trodden area, so we might think that it's an acquired skill. Okay, why might we think that mind-reading proper is an acquired skill? Well, because as we know, children fail classic versions of false belief tasks until they're about 3 to 4 years old, and performance then goes on developing. You can give them more and more complex versions of false belief tasks, and they get better and better at passing these things as they get older. So there's a kind of developmental improvement relation. Also, acquisition of mentalising vocabulary is an accurate predictor for performance on false belief tasks. The more a child uses terms like belief and desire in their vocabulary, the better they're going to be at passing false belief tests. So again, you might think that it's something to do with the acquisition of those expressions that helps them out with the passing of the tests. And subjects can be taught to get better at this kind of thing. You can teach subjects to be more empathic towards others through various training mechanisms. And in certain kinds of impairment cases, you can teach individuals to get better at mind reading. So one of the approaches for subjects on the autistic spectrum is to try and teach them alternative coping strategies for recognising mental states in others. So it looks as if you can get people maybe to acquire aspects that they were lacking originally. Okay, and this is a really throwaway point that I have no idea about, but I've put up in case anybody else has a good idea about. It seems at least plausible to me to think that there may be cultural and regional differences in the kinds of mentalising explanations people give. You may find a variability here that might again suggest to you that it's an acquired but an innate skill. So there's some evidence pointing to the idea that the mind-reading capacity is something we acquire, but there's also evidence that the capacity is innate. So, as I'm sure everybody in the room knows, although we fail false belief tasks until we're about 3 to 4 years old, if they're verbal false belief tasks, there's strong evidence that we pass them from a young age if they're framed in age-appropriate ways. So the famous work where false belief tasks are done in terms of preferential looking seems to show that infants as young as 15 months are able to attribute beliefs to others and reveal that via their preferential looking. And again, the thought is that that's so young that children haven't had a chance to acquire this kind of capacity by that age. And the old point from the folk psychology debate, children receive little explicit instruction. There's a kind of poverty of stimulus about folk psychology, yet they still coalesce on a pretty universal framework which appeals to unobservable mental entities. And you might think that explaining that fact requires positing some kind of innate framework already in place. And I think the point about language on the previous slide would be misleading because it seems to me that typical language development requires mind reading and therefore is unable to act as a precursor to it. Okay, so experiments showing that children don't acquire new terms unless they are given to them by something that they view as an intentional agent. So if you shut a small child in a room and you film them, and the room is filled with objects that they know, but there's one object that they've never come across before. When they pick up the object or they fovate on the object that they've never seen before, if you boom out over some loudspeakers, that's a mech! It's a mech! The kids don't learn that word as a label for that object, because it seems that labelling that object, what they require is joint attention with another agent. And that seems to show that, you know, it's the mind reading that's underpinning the language, not the other way around. And some work by Michael Platt, forthcoming, seems to show that the brain structures that are responsible for the mind reading or the social cognition in the primates and in the humans have deep similarities. I don't know how much weight to put on this, but at least one thing you might think of it is as showing that there's a really strong evolved component to the kind of thing that we're doing here, which again might speak against the idea that what we have is an entirely acquired or learned capacity, might point us towards an innate capacity. Okay, so just to conclude then, I've been interested in the question of how we engage in behaviour prediction and explanation. And I think it's right. I think that the guys who like deflationary accounts of social cognition are onto something. It's right that quite a lot of the actions we engage in, or the action prediction we engage in, does go via this simple behaviour tracking, statistical regularity kind of model. And maybe what's underpinning that really is a mirror neuron system that's just sensitive to kind of motor contingencies. But it would be wrong to think that that kind of recognition of stereotypical behaviour is the only thing we need, or usually the only thing we need. Because very often we still need genuine mind reading. We need it anytime we engage in counterfactual reasoning, or in language interpretation, or in considering another as a given individual. So I think we need both systems, and we need them both pretty much equally. And the distinction between the two systems for social cognition is orthogonal to issues of speed or conscious access or any of the other things that are supposed to be hallmarks of standard two-system accounts. Behaviour tracking systems, I think, are best understood as learned associations. So I like Hayes' account of the mirror neuron system as a learned system for behavioural regularities, and I think if you take it that way, the literature about mirror neurons becomes much more interesting and divorced from some of the really overblown claims that were sometimes made for the mirror neuron system. So behaviour tracking is a learned association, but mind reading still seems to me the kind of thing that you want a nativist account of. It's because of its early onset, its appeal to unobservable entities, and its reliance on abductive inference. I think it's going to require a significant innate component. Okay, and that's it.
two questions, one about the big picture and another about a particular point. About the big picture, it seems to me as if you are making a choice between two possible explanations, the mind reading explanations and the smart behavior explanation, and you are assuming that the behavior reading explanation has to be explained in, so to speak, behavioristic terms or something like that, that because it is behavior reading, you need an explanation based on associationist devices like those appear to in behavior. But it seems to me that you are forgetting the smart part in a smart behavior reading explanation. The fact that you are tracking someone's behavior doesn't mean that you don't need some thinking to do. The point is what kind of thinking you have to do. Do you need the full apparatus of mental state attribution that mind reading theory appeals to? I think that you don't. You can consider an analogy when you are trying to understand, for instance, a complicated machinery. You borrow my annoying cell phone, for instance, and you wonder it is sounding. You wonder how to switch it off, and then you figure out that you have to press this or that key. If the thing is designed in a user-friendly way, it will be simpler. This is part of the point that we were arguing for yesterday with the mind-shaping view. But the thing is that you don't have to attribute mental states or anything. You are tracking the behavior of that stuff, and you have to do some thinking. But not the kind of thinking that the mind reading theory.
Yeah. Okay. So just sorry, you've got two responses to that one. Absolutely. I mean, I completely agree. So, apologies if I gave the impression that the behaviour tracking system is a behaviourist system. I think that's absolutely right. It's different from old-fashioned behaviourism. And I think Povinelli is really good on this point, actually. He says, look, it's behaviour tracking, but it is, as you say, smart behaviour tracking. So there's all these kinds of cognitive skills that we want to give to the animal. The only thing we're not giving them is the positing of the unobservable mental states. So I want to grant all of that. I want to say that the smart behaviour tracking system really is smart in all those ways, that it can track the variant and the invariant features of the situation. It can track whatever else it needs in a non-mentalistic kind of framework, and perform all kinds of smart calculations over that. The statistical relations aren't going to be just brute, they will be sensitive to a range of different features. But it still seems to me that even if you give all of that to the behaviour tracking system, you still have this gap. We still have a gap between a system which assigns mental states and a system which doesn't. And I think that the system which fails to assign mental states will still fall down on any of these, cases that I gave you. It won't get the language, it won't get the counterfactual reasoning, it won't get the character-based attributions, and I can't see what you could give to the system short of consideration of mental states that would get you that stuff.
Yeah, I agree with the gap thing. The question is how you fill the gap, and this is also related to my second point, the particular point, which is your example of when we attribute some character trait to a person, and your argument is that you have to attribute mental states to that person. But it seems to me that with character traits it's just the opposite. They are the prototypical dispositional traits that you have to simplify behavioral prediction for an individual. If you attribute somebody the trait of being generous, and you are asking money for anything, you would predict that she will give you money. And you don't need to read her mental state at all. That's precisely what the role of just simplifying traits in just...
Okay, well, I think there are two different ways. I mean, so I think the natural response, you're absolutely right, to my claim about character traits would be to think that, you can give a kind of deflationary account of character traits in just the same way as you might give a deflationary account of other kinds of mental states. Maybe the character trait of being generous just kind of reduces down to a tendency or a statistical regularity between being asked for money and giving money, for instance. And then you would have an account which would allow, you could appeal to those kind of character traits without thinking about mental state attribution. I think that's quite what you were saying, because it sounded like these were going to be generalizing features that allowed you to class these actions together without reducing them. And I think if you think about them in that way, it's not clear to me that you're not thinking about them as mental states. What is the thing that's doing
example, what is the mental state that I'm attributing to Jill in your example?
Well,
I mean, I'm predicting her behavior. What is the mental state that I'm attributing her?
Okay, so what I want is a more generous account of mental states. Okay, so really quickly. So traditional folk psychology says, you know, belief and desire prediction is a classic case of behaviour prediction, and that's really, you know, we just need things that look like that. I do think that's too narrow, right? We want a more pluralistic account of what's going on in mental state attribution, or what counts as a mental state. And I think these kinds of character traits should be counted as having explanatory work and as being genuinely mental, even if they don't look quite like beliefs and desires. So, yeah.
Eddie?
On your list of problems for behavior reading accounts, it could be longer.
Okay, sure.
So let me just make one suggestion, and this may just be because you're trying to be brief, so this might connect up with your circularity objection, but I would have thought a kind of standard response to these is that these accounts are inevitably somewhat piecemeal compared to a mentalizing account. Because things that are treated as the same type of event on a mind reading account, that's a false belief scenario, would have to be, well, that's a behavior of this particular more fine-grained type. Here's another one, to explain all the variety where the agent who's willing to do a mentalistic attribution collapses all this and can have a productive explanation. This connects with the baby work. I noticed that, I mean, this was just in passing, but you just gave the one classic study from 2005. There's really a very rich series of studies that have followed. And one of the things that's really fascinating about that work is how much variety there is in the scenarios, behavioral variety in the scenarios that the babies are responding to when you give them spontaneous, non-linguistic tasks. So just in the false belief case, for example, at the same young ages that you can get, younger than 15 months, that you can get babies to respond to a false belief task about object locations, you can also get them to do a false belief task for object properties, or also for object identity. And these are all clustering.
Yeah.
If it's a behavior reading account, that's somewhat mysterious. Why would these all just sort of pop in together?
Yeah, I mean, so I didn't mention that, and you're right that that is a kind of classic objection to these kind of approaches. I think you're right, it does relate to the sort of circularity worry about how we're setting things up. But I also am a little bit not absolutely clear that I buy into that as an objection, just because it's a sort of appeal to simplicity and how many rules you need, and I do feel some sympathy for the advocates of the behaviour approach when they say, you know, but we haven't seen the fully worked out mind reading account. How do we know that that's going to be simpler? You know, Chris likes this one.
I don't think people who hold this kind of view would just say it's simpler. They just say that there's a greater explanatory depth, right? So that I predict that if the baby can do this, it ought to be able to do this other thing. Now let's go test it on this other thing. So it's making a productive prediction, which is then empirically confirmed.
Yeah, but then I think the behaviour reading account, if you do plug in the sort of the smart bit of the behaviour reading, you know, it's going to depend a lot on how you're spelling out these kinds of associationist rules, and that is a really big problem, and it's a really big problem for the associationist literature. But assuming that there's a way to answer it, they're going to have a degree of broadness about the associationist rules that isn't just a one-to-one mapping, because any kind of associationist account isn't going to want, you know, a really tight congruence between the action and the rule. So there has to be a bit of scope in there for them to get this kind of generality.
Well, that's where the folks who have this objection will say the cheating is happening.
Yeah.
Yeah. I would have several comments, so I try to be short and then we'll continue. The broad comment is that I almost like everything you said, which is extremely rare. But I have two main comments, and then I have details that I can talk to you about later. The very first one is this one. I think that your arguments are more general than the way you present them, and I would stress that because there are reasons to believe that there is no such a thing as a mirror system. As it has been defined. And the articles that are referenced here are a couple of articles by Gerber Chibra, who showed that really the system is a system of goal tracking, and the reason why it's not a mirror system is that it can also track goals of agents who do biomechanically impossible actions, which is not compatible. That's why your argument is more general, because you could say, and I think it's very useful what they're doing, you're saying even if there is a mirror system, this is what happens. But I would stress that you're not in any way bound to believe that there is a mirror system to begin with. And in fact, the right way to me to read the results that you presented about the fact that this mirror system can be trained is not to say that the mirror system can be trained. It's just to say that there is no such thing as a mirror system, and these things are just reflecting statistical relations.
Yeah, okay, so, I mean, so the history of this is that I've published a couple of things being very sceptical about the mirror neuron system and arguing that it doesn't really exist, or at least it doesn't exist in humans in the way that they think that it does, and that it's hugely overblown. But so I'm very sympathetic to the idea that it doesn't exist or that it doesn't do the things that we're interested in. But it's certainly doing something. Like there is a finding that you have these neurons that fire in distinct conditions, and that's interesting in itself. And it seems to me that it would be good if we had an explanation of what they're doing. And it may come down to the fact that it is just about a motor map that's going to allow us to map seen movement to felt movement. And maybe you don't want to call that a mirror system in the end. The terminology is going to turn out to be not that interesting then. But whatever,
but it cannot be a motor map because you don't.
Because you have the biomechanical.
Yes.
Yeah.
It just cannot be. So it's all throughout, all through. It's just associations and goal prediction.
Yeah.
Okay, let's move on.
Yeah, okay. And goal is such a loaded term in this area anyway because it can mean so many different kinds of things.
In this case, it really means intention. So the point is, you would, if I were you, I would stress that your arguments concern the possible neural system, but they're really just much more general. Because if you even other solution that you can give to this thing, they still, your arguments still apply.
Yeah.
Right?
Okay. Good.
So that's the first point. The second point is that very simple then, very quick. I think that you are completely right about the fact that we should forget about the dual system theory in the application here and in many other applications for that matter. But you are doing the same mistake, in my opinion, because you are also proposing two systems. You just say that, and I don't think that you have reasons to believe that there are two systems in any sense of this name. And the short one is the following. Some time ago, Jerry Fodder wrote an article in which he argued that in 99.9% of the cases, you can do without using false belief attributions to explain behavior. And he has this idea. 99% of the cases you have a standard way, which is you use only desires, and you explain everything on the basis of desires, right? You need beliefs, only in certain particular cases in which this first kind of default application fails. So the system is still a belief-desire system, but the point is that you might not need, in many conditions, to apply anything else than satisfaction of desires, like drinking glass, without any beliefs. And then, if this first part doesn't work, you're going to have the second pass available. But that doesn't constitute two systems. It's the same system. So, if you want to deal without mathematical things in the world, first thing you try to see we can make a subtraction. So, for example, you go buy some stuff. These subtractions are not available. You probably go to divisions. Divisions are just more complex, but it's not that you have two systems of mathematics. One for subtraction, one for division. It's that for any kind of this kind of thing, you have like defaults, and that's all over the places, right?
Yeah, I mean, so one way of thinking about this is that, maybe you've just got some heuristics that let you get going on the first base, and then if they don't work, then you go to something else. Yeah, I mean...
It's more than heuristics because you have lots of loaded information you need to cross and so on, but... so the point of pulling back from classic two-systems account was to kind of, weaken the impression that it's a two-systems account. I'm not sure that I would want to say that, I haven't read the photo paper, so I don't know. I'm not sure that I would want to say that in all these kinds of stereotypical cases, we've just got an explanation in terms of desire going on that. I think so. But
sounds okay. But so maybe that is a possibility. But I kind of like the idea that it really is, two systems always sounds like two big things doing totally different things. We might not want that, but we have evidence about behaviour, and then we have thoughts about minds, and they don't have to be observed by exactly the same kind of system, I guess, as well.
Okay. Are there any other questions? Very brief question.
No. Back to your time? Oh, we didn't pick your hand? Alright, so can you tell me where I can go to find a well-worked account of how, from a person's overt behavior, an observer is supposed to infer the underlying mental states, and from an attribution of the underlying mental states is supposed to infer the behavior that can be expected?
So what do you want from a well-worked out account?
An account.
Okay, well, from your behaviour so far, I'm forming the idea that you don't like this kind of approach, and so I'm predicting that you're not going to find whatever answer I give to this satisfactory.
You didn't tell me, though, how you make that inference. What's the theory that tells that mediates the inference from the observations of the behavior to conclusions concerning the underlying mental states? Just to elaborate my skepticism a little bit further, all I ever hear when I ask this question is, people do what they believe will satisfy their desires. Professor Nadi said that yesterday. But of course that is not a theory, that's not correct. People always have lots of desires. If you try to formulate a principle like that doesn't deny the obvious fact that people always have lots of desires, then you got nothing. Nobody's ever explained what the connection is between belief and desire, such that given these beliefs, and these desires, and these preferences, and these beliefs, and these strengths, we can expect a certain behavior to come out. So I don't really see that you offer that there is an alternative. Maybe all the behavior reading theories failed, but to presume that leaves us with the mind reading theories, presume that there is a mind reading theory out there to move to in that case. And I have never seen one.
But the fact that we have multiple desires, I'm not really seeing why that's...
What's the principle?
Well, look, we rank them, right? So I have loads and loads of desires, but presumably some things I desire more than other things, and some things I think more likely to come
but then the beliefs, what you act on will depend on how likely it is you think you can satisfy a desire. So you might move to satisfy a less preferred desire, a less highly ranked desire, because you think it's more likely that you can satisfy that desire than that you can satisfy the more highly ranked desire. And so then that takes us to decision theory. But decision theory isn't really a predictive theory. So I can't, without giving a lecture, say more about that. But you have, where's the theory? Where can I find it?
Well, I mean,
citation.
So how about vision theories? There are many around which are actually computationally quite
decision theory.
Not necessarily decision theory. There is theories about belief design psychology with vision, evaluation of the priors on the basis of behavior.
Can you tell me the name of the author?
Teneman. Josh Teneman, and I can give you kinds of...
I mean, usually when you talk about utilities, that's inferred from choice behavior. So the utilities aren't given so that you might then infer the choice behavior from the utilities. You have to calculate the utilities only once the...
the idea is you adapt your prior when you see the behavior by modifying the metrics of utility of the person. But there are attempts to do that, and they're quite elaborated.
Yeah, and no one's going to say it's easy. It's not like it's easy to construct a theory of these things. But the alternative is that it's totally, theoretically intractable, and I don't see any evidence.
I look at the Tenenbaum and haven't done that, but despite working in the field for a lot of years, it's never come before my eyes.
Okay.
Thank you very much.
Thank you.
We have 50 minutes for our break.
We'll be back at
One thing is,